మేము everyone mute your microphone.
Sir, it's not audible. Unmute yourself.
సార్ ఉన్నారు.
Oh, sorry. Is it clear? Is it audible?
Yes, sir.
Yeah, sorry. Now,
Yes, sir.
when we are going to observe the inclusive class interval, this is the inclusive class interval 15, 19, 20, 24, 25, 29, 30, 34, like that. Now, when you have to compare the marks, the number of students in a class of the marks between 19 to 20, no one can got the marks between 19 to 20 and 24 to 25, like that. Therefore, no need to any problem to solve the problem, no need to any question or solving the problem. Suppose when you have to observe the ages of the persons, like this, 19 to 15 to 19, 20 to 24, 25 to 29. There is a question arises, what is the ages between 19 to 20 and 24 to 25? That means this type of ages, when you have to take the ages, it leads to the continuous frequency distribution. Continuous frequency distribution or continuous frequency data. When you have to observe the data, we have to choose the class interval regarding that one also.
Screen is not visible, sir.
Emma? It is visible or not?
Visible, sir.
Audible?
Yes, sir.
Yeah. Now, if you deal with the continuous variable, if we deal with the continuous variable, it is not possible to arrange it is not possible to arrange the data in the class intervals of the above type, that is inclusive type. Is it right? Now let us consider the ages of the distribution of the ages of the age in year. Consider the distribution of ages in year. If the class intervals of the above type that is 15, 19, 20, 24, etc., 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 then the persons with the ages between 19 to 20 are not taken into consideration. In such a case, we form the class intervals class interval as shown below. That is like this. That is from 15 to 20, 20 to 25, 25 to 30, 30 to 35, and so on like this. This form of the frequency distribution, with such classes is known as continuous frequency distribution. Is known as continuous frequency distribution. Now, in which upper limits are excluded, from the respective class. From the respective class and are included in the immediate next class. Immediate next class. Immediate next class are known as exclusive classes. Exclusive classes. This is very, very important. While going to study this one, what is inclusion, what is exclusive? Is it very, very important? Now we are studying with the histogram. Next we are studying the histogram. Now histogram means it is just nothing but a bar graph. Histogram is a graph. Histogram is a graph in which classes are marked on horizontal axis and the frequencies are relative frequencies or percentages. Relative frequencies or percents are marked on vertical axis. Vertical axis. That means on horizontal axis is nothing but x-axis, vertical axis is nothing but y-axis. Now the frequencies and relative frequencies are represented by the heights of the bars. That means the frequencies are represented as the heights of the frequencies and percents are represented or marked by heights of the bars. Height of the bars. Now the histogram, the bars are drawn adjacent to each other. This is very, very important. In histogram, the bars are drawn adjacent to each other. This is very, very important. That means in histogram, on x-axis you have to take the marks or class interval like that. On y-axis, frequencies or relative frequencies or percentage that we have to take on y-axis, and we have to draw the bars, heights of the marked as the represented by the bars. In histogram, bars are drawn adjacent to each other. Now the most common shapes of the histogram are, generally the histograms are like this. That is, this is one type of the histogram, and one is like this, and other is like this, or some other it may be like this also. This is symmetric. These two are asymmetric. And this one is uniform or rectangular. This one is symmetric. These two are asymmetric. That is skewed to left. This one is skewed to right. And this one is uniform or rectangle. When you draw the like this, these are the histograms. This one, this known as the symmetric histogram. Symmetric histogram. This one is skewed to left. Skewed to left. This one is skewed to right. And this one is uniform or rectangle. Uniform or rectangle. These are the different ways of histograms that you have to draw for the different types of data on continuous frequency distribution. Now, a symmetric histogram is identical. Now, you have to explain it legibly. A symmetric histogram, a symmetric histogram is identical on both sides of its central point. On both sides of its central point. And a histogram is non-symmetric. These two are non-symmetric. A histogram is non-symmetric. That is asymmetric. Non-symmetric means asymmetric. Now, for skewed histogram, if the tail is leads to left side, it is known as left side skewed. If the tail is skewed to right side, then it is known as right side skewed. That we have to note down also. For skewed histogram, the tail on one side is longer than the tail on the other side. Is longer than the tail on the other side. That means one side is the longer tail, other side is the short tail. Then such type of histograms are known as skewed histograms. Skewed histograms. Now, a skew to right histogram, a skew to right histogram has a longer tail on the right side. While a skew to the left histogram has a longer tail longer tail on the left side. On the left side. Now, suppose it cannot be skewed to left and not skewed to right, and is also not symmetric. It is not symmetric and non-symmetric also, and it will be in the form of a rectangle like that. A uniform or rectangular histogram, a uniform or rectangular histogram has the same frequency has the same frequency for each class. This is the regarding histogram. Now we see some examples related to these type of histograms. Let us discuss some examples related to this one. Now, the following table shows the heights of 100 male students. Problem. The following table shows the heights of 100 male students at J&K University. J&K University, for example. Now let us take the data like this. The following table shows the heights of 100 male students of the university. Draw the histogram. Draw the histogram. Now see the heights of the and number of students. Heights in inches. Next, number of students. This one. 60, 62, 63, 65, 66, 68, 69, 71, 72 and 70. This is class interval, and again corresponding frequency 61, 64, not sorry, now first you have to write the frequency, that is 5, 18, then 42 and 27 and 8. Now adding all these frequencies, how much? This is 27 plus 8, 35, 35 plus 42, 77, 77, 85, 95, 100. Total is equal to 100. Is it correct? Check all of you. This is 100 male students. Frequency is equal to 100. Now, when you draw this one, 60 to 65 is equal to 5. 63 to 65 is equal to 18. 66 to 68 is equal to 42. 69 to 71 is equal to 27. 70 to 74 is equal to 8. Here is a problem. What about the ages between 60 to 63? Some students are there, but they are not representing here. Therefore, for simplicity, we have to take the midpoint of the class interval. When you draw for this type of problem, you have to take the midpoint. What is the midpoint of these two? 60, 62. Midpoint is equal to 61. Okay. Then next, 63, 65, 64. 64 is the midpoint. 66, 68, 67 is the midpoint. 69, 71, 70 is the midpoint. And 70 to 74, 73 is the midpoint. This is the finding the midpoint of this one. And we can draw the histogram like this. On x-axis or horizontal axis, that is 60, 62, I shall move into the next phase. Note on this one, all of you. Respond anyone? Okay. See, this is vertical line, this horizontal. Now midpoint 61, 63, no, not 63, it is 64, I think. And 64, then next 67, then next 70, then next 73. But in our on y-axis 10, 20, 30, 40, 50. Okay. Now midpoint is equal to 61. Therefore, this one from 60 to 62, 60 to 62. What is this value? 5. Frequency is equal to 5. And 64 to this one. What is this one? Next frequency is equal to 64 is equal to 18. Then next 67 is equal to 42. Then next for 70, 27. This one. For 73, 8. This is the histogram by taking the mid values. When you have to take the measuring the mid values, and we have to draw the histogram like this manner. In x-axis heights, on y-axis frequency. On y-axis frequency. Okay, and we have to see the one more example. This is inclusive type. Now we have to see the exclusive type problem. To the following data, draw the histogram. Draw the histogram. Class interval. This is here we are taking lifetime. Another one, frequency. Now 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, 11, 12, 12, 13, 13, 14, 14, 15. This is exclusive type. And here frequencies are 2, 5, 12, 25, 58, 41, 43, 7, 6, 1. This is the class interval and corresponding frequency. We have to observe the histogram. Up to 15 we have to take on x-axis. 1 for conveniently starting value is starting from 5. For conveniently I am taking 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. On y-axis, frequency 10, 20, 30, 40, 50, 60. This is the frequency. This is class interval, lifetime. Now, what is the first one? Between 5 and 6 frequency is equal to 2. 5 and 6 frequency is equal to 2. This one. Between 6 and 7 frequency is equal to 5. Like this. Next. Between 7 and 8 frequency is equal to 12. Like this. Between 8 and 9, 25. Nine and 10, 58. Next, 10, 11, 41. 11, 12, 43. 12, 13, 7. 13, 14, 6. 14, 15, 1. This is the histogram. Right? This is inclusive type. Inclusive type or exclusive type? Anyone? This is exclusive type. Okay, and then one more example that we have to see. We have to take that one. And joining the midpoints of histogram, this is known as polygon. Joining this one like this. This is known as polygon, frequency polygon. Frequency polygon. While taking on y-axis cumulative frequencies that we have to take, then the obtained graphs which are known as ogive graphs. Cumulative forward or ascending cumulative frequency and descending cumulative frequency, taking on y-axis and x-axis, we can find out the histograms which are known as the ogive graphs. Ogive graphs. And the intersection of two ogive curves is known as, anyone? That you have to tell me tomorrow. Okay, and we have to see one more example. That is a simple example that you have to note down here. Out of 27 randomly selected families, out of 27 randomly selected families, in a small town, the following data give the following data give the number of children less than 18 years of age. Note down the data: 1, 0, 2, 4, 4, 2, 3, 2, 0, 2, 0, 0, 0, 0, 1, 4, 0, 2, 0, 2, 0, 2, 0, 2, 3, 2, 1, 2, 2. Note down these values, all of. Okay, note down the purpose. A. Construct a frequency distribution. Construct a frequency distribution table using single valued class. B. Compute the relative frequencies and percentages for all classes. C. Find the number of families with one or two children less than 18 years of age. Find the number of families with two or three children less than 18 years of age. Yes. E. Draw the bar graph for frequency distribution. Frequency distribution. So this is the question. Already this type of problem yesterday we are solved. And one more problem that you have to take here as like this. Thus this one you have to solve as a practice problem at your homework. It is very simple. Okay. Then again one more problem that you have to take here for practice. 5 coins were tossed thousand times, and each toss of the number of heads was observed the number of tosses during which zero, 1, 2, 3, 4, 5. That means no head, 1 head, 2 head, 3 head, 4 head and 5 head. Heads were obtained is shown in the following table. construct a histogram of the number of heads. Number of heads. Number of heads and number of tosses. Number of heads, number of tosses. That is bracket lo frequency. 0, 1, 2, 3, 4, 5. Frequency 38, 144, 342, 287, 164, 25. Now, for this data, we have to draw a histogram. With this, the simple problems related to the histogram is over, and in the next class, we move into the next topic, that is known as measures of central tendency. And today we have one more class is there, that is starting from 2 to 2:45, because I think it is Python's class or DLE. KB sir's class is there. He has some work, therefore he is not able to take the class. I will continue his class tomorrow today at 2 to 2:45.
Attendance we download.
Okay, you have any doubts?